Hello and welcome to Auten Math. In this edition of Auten Math, we're going to take on some practice problems involved in relating lines and planes in space. So first question, the figure is a square pyramid. How many planes are determined by its vertices? Well, there are 5 that are pretty easy to see. I have the plane ABP. That's one side of the pyramid. I have BPC, another side, CPD, another side, and PDA, another side. So if we were to draw that, so I have here one side, I have another side of my pyramid, a square pyramid here, I have another side here, and then I have another side here, and then of course I have my base, right, which we'll mark back in red. My base is here. So ABC, APB, BPC, CPD, and APD all determine 5 planes. Now we also have 2 other planes that might not be readily apparent to you. And one is, there are actually 2 that slice the pyramid right in half. One is DPB and the other is APC. So DPB cuts that square pyramid right in half, that's a plane. And then CPA is another plane that's determined by its vertices. So I've got 7 total planes determined by the vertices. All right, my next question, I have triangle ABC. It's congruent to triangle DBC. And I want to prove that triangle AXD is isosceles. All right, so we're going to mark up the diagram and then we're going to go through the proof. So the first, this is what I tell my students, you need to mark up the diagram, figure out what path you're going to take, and then go ahead and write it down. So we don't want to meander while we're figuring out the proof, or how the two, actually how in this case AXD is isosceles. So what we want to do is we want to figure that out first, figure out our path, and then go ahead and write that down in our 2-column proof. All right, so the first thing that I know is that ABC is congruent to DBC. So ABC congruent to DBC. So I know that AB is going to be congruent to DB. Then I know that angle DBC is going to be congruent to ABC. All right. Now I can say that BX is congruent to itself. And let's just mark that in red. So BX is going to be congruent to itself. So now I have a triangle DBX, which is congruent to triangle ABX. So I'm going to write that down as well. Triangle DBX, triangle DBX is going to be congruent, and that triangle is kind of ugly looking. DBX is equal to, or congruent to ABX, triangle ABX. And because DBX is congruent to ABX, I have AX congruent to DX. All right, so if I have ABX congruent to DBX, then AX is congruent to DX. If AX is congruent to DX, then I know that AXD is isosceles. So let's go through the proof. I have triangle ABC congruent to DBC. That's given. AB is congruent to DB. That's by CPCTC. I know BX is congruent to BX. And that's by the reflexive property. So let's just adjust this here for a second. I know angle ABC is congruent to DBC. ABC is congruent to DBC by CPCTC. And I know triangle ABX is congruent to DBX. So ABX is congruent to DBX. DBX by side angle side. Now I can say that AX, and we'll mark this up again, AX is congruent to DX by CPCTC. And if AX is congruent to DX, then triangle AXD is isosceles by definition.